In this video, I'm going to talk about ranks. I'm going to describe them a little bit, and then I'm going to show you how to calculate ranks for a set of data. So ranks are standardized scores, as I mentioned in the textbook. And standardized scores have been transformed from raw scores, and they have been done so usually because they are easier to interpret than raw scores. So in many scientific disciplines, particularly the behavioral sciences, I would say, the raw scores obtained from a measure are not that interpretable. But if we transform them into a standardized score, they can be interpreted in a meaningful way, and ranks are one of the most basic standardized scores that can be calculated. Ranks range in value from 1 all the way to n. So 1 is the lowest value. You cannot get lower than 1 for a rank. There's no such thing as a rank of 0 or a negative 3. 1 is the lowest. And the highest rank a person can get, or a case, is n, where n is the sample size, the number of observations in the data. So all ranks are going to vary from 1 all the way up to the largest number of n. So ranks essentially represent raw score values from lowest to highest. The lowest value will get a 1, and I should say typically, because you could flip it over, and I'll mention that in a minute. Typically, the lowest observed score, non-transformed score, raw score, will get a rank of 1, and the highest raw score will get a rank of n, whatever the sample size is. So here's the example that I'm going to use. It's one that I show in the textbook. And the first step to ranking data manually is to sort the data from lowest to highest. And in this case, the lowest sleep score, apparently someone only sleeps 5 hours a night, and I've sorted it from lowest to highest. A couple of people sleep 9 hours a night on average, 3 people 8, and 4 people 7. And then once you order from lowest to highest, you actually give a value from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'll actually show you that on the other slide. You give a value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 from top to bottom. And then you attribute a rank for each case. But what you have to take into consideration is whether there are ties or not. And in this case, the value of 5 and 6 is unique. There are no other people that reported 5 or 6. Therefore, we give them a rank of 1 and 2. But then things get complicated because 7 people reported that they sleep 7 hours a night. And the ranking keeps going down 3, 4, 5, 6. But all 4 of these people actually have the same amount of sleep. And so I actually have to average the ranks and give each case an average value. So I'll show you exactly what that means. So in this case, 4 people reported 7. And I've got rank of 3, 4, 5, 6. So I'm going to go 3 plus 4 plus 5 plus 6. And I'm going to divide that by 4, which is the number of people who reported 7. And I get an average rank of 4.5. And so that's why I gave these people all a 4.5. They have a rank of 4.5. And then these people got a rank of 8 because that's the average of 7 plus 8 plus 9 divided by 3. And then these people got a rank of 10.5 because they reported 9, which is equal. 10 plus 11 divided by 2 is 10.5. And so in these data, we have a rank from as low as 1 to as high as 10.5. Now I should say there's no hard rule that says you have to give the lowest sleep value the lowest rank. Most people would expect you to do that, but you do not have to do that. You could give this person a rank of 11 and this person 10, 9, 8, 7, 6. You could do it backwards and then calculate your ranks that way. You just have to tell the person you did that, otherwise you might confuse them. So typically I would rank highest to lowest numerical values with highest to lowest rank values. So that's a description of ranks. The easiest, most intuitive way to create transformed scores. It requires very little knowledge of statistics, and it is a way that most people actually understand without having any knowledge of statistics themselves.